Hello and welcome to the second session of separation science. It is a general observation that a beginner student always struggle to separate a binary mixture successfully and hence identify the two organic components correctly. It is rather a simple challenge to overcome. This experiment is important because not only it builds sufficient skill in handling the required chemicals and apparatus, but also habituates the beginner student in thinking rationally, helps them correlate their observations to the results collected in the experiment. In the further slides, we shall see few such rationales, correlate few rationale to the probable observations we are likely to get. Testing the presence of nitrogen atom in the binary mixture helps a great deal in separating it successfully. Organic compounds are composed of only 10 elements. Carbon and hydrogen atoms are invariably present, as all the compounds in an organic lab are organic. They are composed of carbon and hydrogen atoms. Apart from carbon and hydrogen, other important atoms constituting the organic compounds are nitrogen, oxygen, sulfur, phosphorus, and the four halogen atoms fluorine, bromine, chlorine, and iodine. The presence of nitrogen in the binary mixture confirms that one of the two is either an amine or a hydrazine or a nitrile. If all these three are absent, then the nitrogen carrying compound which is present in the mixture as indicated by the presence of nitrogen may be either an amide or a nitro compound. Let us now see one by one what the presence of nitrogen in a binary mixture indicates. A nitrogen containing compound, when it is present in a binary mixture, then the binary mixture is bound to contain either an amine or a hydrazine or a nitrile. The amines may be either primary aliphatic amine, primary secondary aliphatic amine, or tertiary aliphatic amine. Or it may be aromatic primary amine, aromatic secondary amine, aromatic tertiary amine. Methylamine, dimethylamine, and trimethylamine are the examples of primary aliphatic, secondary aliphatic, and tertiary aliphatic respectively. Whereas aniline, N-methylanilene, and NN-dimethylanilene are the respective examples of primary aromatic, secondary aromatic, and tertiary aromatic amines. One fact regarding all these amines is that all are basic, and being basic, they are soluble in dilute acids, aqueous dilute acids, for example 5% HCl. The other group of nitrogen containing binary mixture are hydrazines, the primary aliphatic, secondary aliphatic, tertiary aliphatic hydrazines. Examples are methyl hydrazine, dimethylhydrazine and ethylmethylhydrazine, or aromatic hydrazines, phenylhydrazine, methylphenylhydrazine, ethylphenylhydrazine. As amines, these hydrazines are also basic and they also dissolve in aqueous dilute acids. Example, aqueous 5% HCl. If not amines and hydrazines, the binary mixture may contain, if the presence of nitrogen is confirmed, it may contain nitriles, aliphatic nitriles such as acetonitrile, or aromatic nitrile such as benzonitrile. While the three groups of nitrogen containing compounds present in a binary mixture are soluble in dilute aqueous acids, the other group, such as amides and nitro compounds, they are insoluble in dilute hydrochloric acid. Although they contain nitrogen, they are not basic, they are neutral. Examples of amides include primary aliphatic, secondary aliphatic, and tertiary aliphatic amide. For example, methylamide, acetamide, N-methylacetamide, and NN-dimethylacetamide. Also in the category of aromatic amides are primary aromatic, secondary aromatic, and tertiary aromatic amides such as benzamide, N-methylacetamide, NN-dimethylacetamide respectively. Unlike their basic counterparts, amides do not dissolve in dilute aqueous acids, and so does nitro compounds. They too do not dissolve in dilute aqueous acids. The nitro compounds example are aliphatic nitro such as nitromethane and nitroethane. For aromatic nitro compounds, we have nitrobenzene, metadinitrobenzene. These are very few examples of compounds, nitrogen containing compounds, which are present in the binary mixture, the presence of which is confirmed by the presence of nitrogen tested by an inorganic test over Lasagna solution. To conclude, I recommend that testing presence of nitrogen in the mixture helps a great deal. It informs us regarding the path which should be taken to separate both. If none of the elements such as nitrogen, sulfur and halogen present in the mixture, no need to test their presence individually after separation. Thank you.